Now we'll talk about the radius of the nth orbit. Consider an atom with a nucleus which is having a positive energy Ze, where Z is the atomic number and that gives the number of protons in the nucleus. And E is the charge of the electron, which is numerically equal to that of the proton. Let an electron revolve around the nucleus in the nth orbit of radius Rn. I am trying to show the electrons revolving in an orbit around the nucleus with the proton and neutrons. By Coulomb's law, the electrostatic force of attraction between the nucleus and the electron is given by 1 by 4 pi epsilon naught into 4 into Ze into E divided by Rn square, where epsilon naught is nothing but is the permittivity of the free space. Since the electron revolves in a circular orbit, it experiences centripetal force that can be depicted as mvn square divided by Rn, which is equivalent to mRn omega n square, where m is the mass of the electron, vn and wn are the linear velocity and angular velocity of the electron in the nth orbit respectively. The necessary centripetal force is provided by the electrostatic force of attraction. For equilibrium from equation 1 and 2, 1 by 4 pi epsilon naught into, so as you know, this is the formulation, which is equivalent to mvn square by divided by Rn. That's nothing but mRn omega n square. So Z is the atomic number and E is the charge of the electron, n is the nth orbit and m is the mass of the electron, v is the linear velocity and omega n is the angular velocity. Equating this condition, you will be getting omega n square, wn square, which is equal to Ze square divided by 4 pi epsilon naught into mRn power cube. Now the angular momentum of an electron in nth orbit is L equal to mvn Rn, that's nothing but mRn to 2 omega n, which is equivalent to your Vn. By Bohr's first postulate, the angular momentum of the electron is given by L equal to nh into 2 pi, where n is the integer and is called as the principal quantum number, and m into Rn square omega n, which is equivalent to nh into 2 pi. That's Wn is equal to, that's omega, that omega n is equal to nh divided by 2 pi mRn square. This is your angular momentum. Solving this equation, we are able to get the radius Rn. As I told, the angular momentum of the electron is omega n square is equal to Z square divided by 4 pi epsilon naught into mRn cube. As you know, omega n is equal to nh into 2 pi mRn square. So squaring both sides, you will be getting omega n square is equal to n square h square 4 pi square m square Rn power 4. So equating the equation both 5 and 8, you will be getting Z square 4 pi epsilon m into Rn cube, and your equation, which is equivalent to n square h square 4 pi square m square Rn 4. Solving these two equations, you will be getting Rn is equal to n square h square epsilon naught pi m Ze square, where Z is the atomic number, E is the charge, Rn is the nth orbit of radius, m is the mass of electron, Vn is the linear velocity, and omega n is nothing but angular velocity of the electron. As indicated, we need to identify the radius of the nth orbit. So Rn is equal to n square h square epsilon naught pi m z square. So from equation 9, it is seen that the radius of the nth orbit is proportional to the square of the quantum number. Therefore, the radii of the orbits are in the ratio of 1:4:9. For hydrogen atom, the atomic number is 1, and from equation 9 we got Rn is equal to n square h square epsilon naught pi me square. Substituting the known values in the above equation, we got Rn radius n is equal to n square into 0.53 Armstrong. If n is equal to 1, the value is R1 equal to 0.53 A. This is called Bose radius.